Great. Well, welcome and thank you for being here. This is a research investigation that Procon Consulting and Virginia Tech are engaged in. We really are trying to see how this technology could be a way to, a tool to verify models that are turned into the owner at the end of the project, as-built models, how they could be considered to be FM-capable models. That's the idea of the project. Using the HoloLens and using pilot projects, we're pursuing to see if that tool with some software that works with the HoloLens, how it could allow us to verify for the owner as-built models.
Hey guys, I'm Anderson Lewis. I'm a construction technology consultant with Procon Consulting. My boss, Steve DeVito, couldn't be here, unfortunately, due to an injury. But Procon, we are a owner's agent rep for construction management, but we work for the technology division. So what we do with the technology division, we help owners develop standards for BIM deliverables, provide quality service and BIM management services, all the way through the upload of that information. And we also do research surrounding construction technology, so you guys don't have to.
And I'm Waleed Thabit. I've been with Virginia Tech since 1997. I actually did my graduate school at Tech at the early 90s, left and came back, and got involved with BIM since Autodesk bought Rivet in the early 2000s, and then got involved with BIM to FM after the born of Kobe. I'm sure many of you know what Kobe is. Anyway, I got involved in that, doing research, and eventually started my own consulting firm, Virtual Facilities Consulting. We have a strong relationship with Procon because the owners of Procon are Virginia Tech alumni, and this is where the relationship came about. Everybody knows this. Deliverables to facility managers at the end of the project are not necessarily what they want, are not necessarily BIMs that actually are beneficial to facility managers. I work with Virginia Tech facilities, and I know that capital project managers, design teams, and construction teams that are engaged in projects on the Virginia Tech campus doesn't know anything about what Virginia Tech facilities want because they don't have any requirements yet. Because of that, Virginia Tech is in the process, as many of you owners in the room, if there are owners in the room, are trying to get to that point where you actually develop your standards and specify what you really want from the design and build team. We're focused in our application here in delivering something that would help the BIM model that designers and contractors develop during the design and construction period to make it an FM-capable BIM. Some people yesterday referred to that as FIM, Facility Information Model. I'm going to keep the acronym BIM, and I'm going to add to it FM-capable, and they all mean the same, something that the owner can really use towards their operation and maintenance. It should have, an FM-capable BIM should have related information to solve operational challenges and improve safety and efficiency of the client. It should have 4 main elements, and we're targeting one of those elements today with our application. It should be a central repository for accurate and reliable data and information. It should provide accurate, complete representation and visualization of the facility being built. And this is where we come in with our potential solution today. It should identify relationships between building components and systems. A system-centric BIM is very critical, and a lot of owners today do not understand what that means. It means being able to connect components and systems across the board so that if you have an emergency, you can respond to that emergency. And we do impact, some of the people in the industry today do impact analysis that would allow owners to understand if a valve goes out or if a panel goes out, who else is connected to it? and you can build that in the BIM model. And then it also allow you to do some analysis, whether it's heating and cooling analysis, lighting analysis, whatever. So converting models to what we call an FM-capable BIM from data such as the Smart Market Report, and this is 2014, has been proven to be the #1 activity for post-construction as defined by contractors. This is some data from the same report. We come somewhere in the middle, but South Korea and Japan are highly engaged in getting that model prepared for the owner at the end of the project before they deliver it to the owner. And so what are we doing here with this project? We are actually taking this requirement, having the BIM model being complete, accurate, and representing of the reality. We're trying to find a way to verify that. And we're doing that by using the HoloLens with some software that works with it, with a pilot project that we've done on the Virginia Tech campus. There's a new, somewhat new standard in the industry referred to as the level of accuracy, and that defines, very similar to the level of development, it defines certain tolerances that some owners are beginning to require in their specification. I want this piece of equipment to be within a certain tolerance from where it is represented in the model. That's becoming to be required. And so we're going to show you how the HoloLens and HoloLive being applied to a project on Virginia Tech. Just quickly give you a background on level of accuracy. These standards are online. It defines 5 levels, LOA 10 through LOA 50, and each one of those levels are associated with inches or centimeters, millimeters associated with the tolerance. This is an example that I've got from a contact that I know from UC Health. This is a piece out of their specification. The record construction BIM shall reasonably match the location of as installed objects in constructed conditions with a tolerance goal of plus or minus 1 inch. Okay? Just to give you a sense of what are we talking about here, augmented reality, we are right in the center of the screen. There's virtual reality, augmented reality, and mixed reality. The reason we have these couple of slides is because I talked to some facility owners, and the differences between augmented reality and virtual reality is not 100% clear to them. So I'm going to do this, and I'm going to be very quick. Virtual reality, when you put your virtual reality glasses on, all you see is the virtual reality. You don't see anything else. You're like in this dark environment with the model in front of you on your eyes in the glasses, or if you're aware of a cave, that's where we can represent virtual reality. Some examples of hardware is the Oculus Rift and the HTC Vive. Augmented reality is intended to allow me to see the model, to see virtual and reality at the same time. So when I put in my HoloLens glasses, they're actually see-through, and there are special glasses allowing the display to display the model, and then behind the model you'll be able to see reality, and that's how you'd be able to compare the two, and that's what we're doing here. Mixed reality is the third piece of the puzzle, and mixed reality is somewhat an augmented reality, except that the virtual world that is engaged with us is actually interactive. You can think of that as something similar to Jurassic Park, where you actually see the virtual dinosaurs running around with reality, okay? So let's talk about the case study. This is a Virginia Tech facility. It's a 3-story classroom building. about 10,000 square feet. Mechanical room, and one of the floors were the target of our study. This was a 2-day pilot project. Procon came on campus. We got together. We went through the technology. We went through 1 day of walking around, 3 of us, Anderson, Steve, and myself. And then the second day, we arranged for facility staff to come to my virtual lab. We made a short presentation to them. We told them what we're going to do, and then we took them in the field and actually tested using the lens and using the HoloLens, and also we use the iPad, and you see in some of the images how they use the iPad. I'm going to pass it on to Anderson to talk about the experiment.
Thanks, Waleed. So when we developed this workflow, there's a much more detailed workflow that we actually developed, but for this presentation, really we can distill that workflow into 5 steps. So first we had to create the augmented reality from the as-built BIM model. Next we uploaded that to the AR-enabled device, and we actually did a parallel workflow where we used the HoloLens, and we actually used an iPad Pro as well, because that may be more practical for some facility managers. We then went on site and overlaid the augmented reality on top of reality where it should exist in the real world. Then we were able to observe the differences between augmented reality and document those differences. And we were able to send that documentation back to the modelers so they could make any corrections that we found. So some of the hardware that we used, Waleed showed you guys the Microsoft HoloLens right there. There were a couple peripherals that we used as well. We had the Microsoft clicker, which is akin to a mouse, or really just the left button on a mouse. We had this Bluetooth keyboard, which came in handy at different times. It just syncs up with the headset. We used the iPad Pro, like I mentioned, in the parallel workflow. The software we used, Visual Live, and basically what this is a software that converts BIM models into augmented reality compliant models, so you can actually use those with the different devices. We use Navisworks as well as Google Drive. So Waleed already kind of introduced the building that we were doing this testing in. There were 2 main areas of interest for us, which was the 2nd floor hallway, and that was because there were exposed ceilings and we could readily compare the model versus what was in place. In the mechanical room, because there was a high density of equipment and we could walk around it and observe the model versus the equipment in that room. So before we were able to do this, we had to go prepare the model, and in doing so, we wanted to basically only show what was of interest to us, and this is the mechanical room right here. The reason being, basically for performance in the headset, you want the model as small as you can get it. I do want to mention here, you can do this with Revit as well, and this process looks a little different. In Navisworks, you have to go through and actually hide all the elements or the objects that you don't want to see. If you did this through Revit, you simply put a section box there, and everything that falls outside of the section box won't show up in the augmented reality model. So that's just one distinction between those 2 software programs.
Interesting, if I can jump here. The model was developed by the general contractor that built the building several years past, and it obviously was not intended to be a facility management model. And so we found a lot of errors, as you'll see. But I wanted to let you know that we did not create the model, and it was given to us by Virginia Tech, and it was given to Virginia Tech by the contractor, but it was the outcome of clash detection models that the contractor did. There was no requirement to submit that model to Virginia Tech. Right.
And while we did find some things that were off, a lot of it did match up pretty much perfectly, so you could tell that it was located correctly in space. So yeah, speaking of locating correctly in space, there were a couple different ways that you could anchor the model into reality. Method 1 was using the QR code. So essentially you would add a little object in your model that represented this QR code. Then you'd print the QR code off and go put that in the same place in reality and scan it with the headset, and the entire model would just locate itself. The other method was the pick 2 points method. So you'd go in your model, pick point 1 and pick point 2. And then you go into the room that you're concerned with and pick those It didn't have to be, the first point had to be the same, but the second point just had to be along this line. So it didn't have to be the same exact distance away for everything to locate correctly. And there was another method, manual placement, but it was too clunky and burdensome to really examine. So here we go. We finally got the augmented reality pulled up in the iPad. This is the Virginia Tech facility manager taking a look at that. And it's kind of hard to tell exactly because we have a different perspective than him, but you can see these two pipes match up with those two pipes. This turquoise object right there corresponds with that light. So in general, things were lining up pretty well. Here's another example of that kind of closer so you guys can see that. This was actually taken with the HoloLens, so it looks a little different. And the 2D image doesn't quite do it justice. When we were seeing this was in 3 dimensions. But as you can tell, the overlay is so good, at some points you can barely tell augmented reality apart from reality. And before I go any further, there's functionality of the Visual Live software program that's worth mentioning, overlay reality. And so what that is, basically, when overlay reality is off, the model takes precedence no matter what's around you. So I would see the model, and even though it's a little bit transparent, I can see reality a little bit in the background. I could only measure to the model. But with overlay reality turned on, whatever is closer in reality takes precedence. So for example, this is a pump, and here's the AR pump right there. But because the real one is closer to me, I'm able to select that. And that's important because without overlay reality turned on, I can't measure from reality to the model. And I'll talk about this a little more in future slides. So here's some examples of the measurements we took. So this is a hot water supply pipe. This was on the 2nd floor in the hallway that we discussed. And as we can see, it looks like that's about 6.5 inches. This is the real pipe. This is the augmented reality overlay. So those don't match perfectly. And you have to take this with a grain of salt a little bit. It looks like the modeled insulation isn't the same exact thickness as reality. But I mean, in general, we know that's about 6 inches off or so from where it should be. Similarly, here is the heat exchanger. And we can see that's about 3.5 feet off. And kind of the same thing. This wasn't modeled with insulation, so maybe that's only 3 feet, 3 inches or so. But we can still tell that's not even close to where it was modeled. So after we take all our measurements, we went through and started capturing images. So essentially, to do that, you would just press Start Capturing, and once you press Start Capturing, it turns to Stop Capturing. You'd take your pictures, and there's a couple opacity settings that you can choose from, and that just, how much of the model do you want to see and how much of reality do you want to see. And one thing worth mentioning here, with Navisworks, when you take pictures, you're actually able to upload from that perspective back into Navisworks as a viewpoint, which for those of you who are familiar with Navisworks is huge, because if you're using Revit, you can do switchback and immediately see the area that those pictures are taken from. At the time of this case study, that functionality wasn't working. I've used it before, but I called the software manufacturer and they said the latest update messed it up, but it should be back soon. So once we take our image, we have to fill out the issue name. We can categorize the image as one of 4 categories, either an issue, an RFI, an observation, or punch list item. Then we can upload that directly to one of our cloud systems here. That's where Google Drive came in, but it also works with SharePoint, Procore, BIM 360, and I think that's it for now. So some of our early findings from a usability standpoint, and when I say usability, I'm referring to the ease of use and learnability of the technology used to carry out this workflow. So some of the positives, it was really easy to set up. It didn't take any time at all. There was ample instructions on how to use the software. There's videos and users manuals, so that was great. It was easy to align the model with reality, and once aligned, the model stayed fairly stable. As long as you weren't moving the headset too quickly, it stayed pretty stable. And it was typically pretty quick to create the AR models, especially if you're experienced with Navisworks. Some negatives, there were some ergonomic concerns. It's about 3.5 pounds, and most of that weight's located at the front, and it doesn't sound like a lot, but when you wear that for half an hour, you start to feel it. Also, some eye strain issues after long enough. We encountered some typing issues. When you're typing using this, you actually have to select each letter one at a time, and they're hand gestures, so this is the equivalent of clicking, so you'd have to do that on every letter. Or you could use this clicker, which sped it up a little bit. Or you could use this Bluetooth keyboard, but that only really worked when you had a surface to set it on. Otherwise, you were hitting each key one by one. And there's voice recognition as well, but we found that didn't work that well in the loud mechanical room, so something to be aware of. Some of the negatives, so we're already on the negatives. So HoloLens software crashed on us a couple times. It wasn't frequent, but it was still kind of a pain when it happened. Wi-Fi availability. You don't have to have Wi-Fi to align the model, but you do to upload the images.
And if I may add, we were in a mechanical room inside the building. Virginia Tech didn't plan to have Wi-Fi accessibility in the mechanical room. It's something to think about with future technology.
And that may be one of the improvements. This is still pretty early, and the HoloLens 2 is going to come out. So it wouldn't surprise me if some of these things are fixed in the relatively near future, but this is an examination of today. Field of view. The field of view of the augmented reality is actually pretty small considering your overall field of view. So that was a little bit of an issue if you're really close to equipment. You couldn't see the entire context of the augmented reality. And of course, there are going to be some safety concerns when you're walking around with obscured vision on a construction site or in a facility. So from an effectiveness standpoint, and when I'm saying effectiveness, I'm referring to the degree to which the workflow and technology were successful in producing the desired result. So the positives, this was very effective as a general model check. We were able to go out there and see, if elements were off. The precision that we could tell that they were off by was another story. It was easy to capture images in the forms of issues, RFIs, observations, etc. The measurement tool accuracy was actually fairly precise. We set up a yardstick and measured it a couple times, and each time we were within a fraction of an inch of that same measurement when we measured it using this. And I think part of that is up to the precision, the user's ability to be able to select the exact point they want to. Some negatives from an effectiveness standpoint, there were visibility concerns caused by reality, and some of those were high elevation, far away objects. And I kind of liken this to, if you were shooting an arrow at a target at 5 feet, it's pretty easy to hit the bullseye every time, but when it's 30 feet away, it becomes more difficult to hit that exact spot you want to. So the further objects are away, the harder it becomes to measure with precision. Line of sight is a limitation. Obviously, if you have this on your head, you're limited to wherever you can put your head to that line of sight, or likewise with the iPad, wherever you can lift that and take a picture. And it's also kind of hard to get some of the measurements with limited lines of sight. Insufficient lighting was an issue as well. In really dark areas, the HoloLens couldn't actually map that area because it couldn't see it, and if it can't map it, you can't measure to it. I only ran into this once, but dark colored objects sometimes didn't show up. For example, there was a valve handle that was painted black, and I was trying to select that, and I just could not. Also, visibility concerns caused by the augmented reality overlay. So some users had a hard time distinguishing reality from the augmented reality, and we found using complementary colors to the objects in reality really helped. So that pump that was red, that's why we colored it green, so it would really stand out and you could tell those two things apart. Also, we encountered some measurement frustrations. Sometimes it would just auto-snap measurements, or sometimes you would click and there was a delay and you didn't think you would click, so you'd do it again, and an entire dimension string would just end up in your model, and unfortunately you couldn't just undo, you had to clear all dimensions. So that was a little bit of a pain point in this process. Oh, and also, the last thing with measurement, it was fairly easy to measure on one axis. If it was just at the wrong elevation, it was easy enough to put that one dimension string, but if it was off on the X, Y, and Z axis, it was definitely a lot harder to take all those measurements and tell the modeler exactly how far off the model was from reality. So, hand it back over to Waleed.
There's a lot of big contractors in the U.S. Using this technology. I I know one in North Carolina that I got in touch with that I saw on LinkedIn that are using this technology for construction purposes. This is a company, this is Kojima Technical Research Institute. I met them in Europe last month. They actually developed their own software, the equivalent of HoloLens. And they're using the technology to verify how they're building the rebar, how they're doing it on site, and whether what they have built is exactly to what the model shows for them. And I thought we're interested in getting in contact with them and working with them because they have developed their own software, and we want to see if their software is more could benefit us to some of the future stuff that we're going to talk about quickly here. So where are we going with this? There's a few ideas that we're going to continue to pursue with this project. One is we want to see if we can bring in the data from the model and be able to verify it in the field. So instead of just looking at graphics, looking at structured information. We're also looking at testing how to modify incorrect information or change information in the field. As we see it, as we see the information on the glasses, can we actually, through different input and workflows, how we can put in new data and then send it back to the model. We want to look at, this is something that really I'm very interested in and talk to Procon about. I want to find a way where I can actually develop, we program, work with HoloLens to actually let the software determine the distances, automatically the distances, the tolerances between reality and virtual and augmented reality. Interactive instructions, we're going to try to experiment with this, how we can send instructions to workers who are doing maintenance in the field. So instead of just seeing the graphics and the data, but also they can see instructions of how to operate or maintain a piece of equipment. And then finally, we want to explore different software, different hardware. We're targeting the HoloLens 2, like Anderson said, and we plan to purchase one or two of them and test them in the next phase of this project. We come to the end. We're going to skip this video. We're going to come to the end of this presentation. We thank you for your attention, and we'll be happy to take any questions. Sir.
You listed all the pros and cons when using this system. I'm curious, at the beginning you stated that you use the HoloLens and also iPad.
Right.
Did you notice that maybe one platform worked better than the other? I mean, it sounds like the HoloLens provides a lot of positives, but
right.
It's in the beginning phase of development. It sounds like there's a lot of issues with using it.
I'm going to let Anderson answer that, but I'm going to tell you my first observation with the facility staff. They were holding the iPad more.
Yeah, I think the iPad is probably more practical. It's easy to just have in your tool bag or whatever, walk out to site and just have that with you. The HoloLens takes a little more effort, and a lot of people aren't comfortable with it. I've heard some people say it hurts their eyes or makes them dizzy, and I don't know if they're talking about virtual reality or augmented reality. This doesn't really hurt my eyes that much, but the study wasn't as much comparing the two. We kind of just, since we had that technology, we decided to test it on the iPad as well. It was really kind of set up focusing more on the heads-up display at first. So we don't have a direct comparison between the two, but I would say for the most part, the outcome was pretty comparable. It's just,
I think the colors on the iPad is better. I think the clarity is better. I think the ease of use, that you have to hold it while you're moving, that's the biggest hurdle. If there's a way, I mean, actually with Anderson and I were brainstorming about, tools that could allow you to wear something where the iPad is, I've seen people in the airport wearing this thing where they can put their phone and they're sitting watching their phone in front of their eyes. So things like that could become handy in the future. But I think if this becomes, if some of the negatives that we have here get resolved with future development in software and hardware, I think this is better because it's hand-free. Sir?
It was difficult to tell from the images on the screen, but when you were looking through the iPad,
Yeah, it's hard to see from where you're sitting, but when you come closer to this image, you can actually tell what's reality and what's not. And we have the iPad here after the presentation. We'll be happy to show you an example. You'll be seeing a ceiling of this room that has nothing to do with the model, but at least you'll see both at the same time.
You used the Navisworks model because you didn't have access to the original Revit source files? Or?
Well, some of the reasoning behind that too is that typically from a contractor, you're going to get more accurate coordination models that are more likely to be in Navisworks format. We could have done it either way in Revit. And one of the other...
HoloLens workflow is pretty much identical.
Yeah. But the other major benefit to Navisworks is the fact that you can open those images as viewpoints in Navisworks, which is huge. So,
yeah, and I couldn't put the Revit models together. They were incomplete.
Okay. And weren't the Navisworks files much smaller?
Size-wise, yeah. Well, once they're actually converted into augmented reality, I think they're converted into something similar to objects, and it strips out a lot of the size. I think, yeah. The Revit models were definitely bigger than the Navis files, though, for sure.
But as far as on the HoloLens and partner of Autodesk, so we've done some testing. It doesn't make a difference what the source authoring application is.
Right.
The cloud application does the conversion down to the format the HoloLens wants.
Yep.
We found the file size to be identical.
Yeah, but yeah, beforehand there's definitely a size discrepancy.
One thing I should add that came to mind is that a lot of the facility staff thought that this would be a great tool as an X-ray tool to see things behind walls and ceilings, because they waste a lot of time trying to figure out whether the valve is here or is it here or is it here. Sometimes they have to knock down a drywall, and they thought that would be a great application. I'm going to go to you first.
So when you put this model in this augmented reality, as you're trying to validate build condition versus the model conditions, are only the differences being highlighted? Or, I mean, if something is placed here but the model is showing it to be here, is that being highlighted, or no, you're having to highlight that yourself? I mean, is it smart enough to know the differences?
Not yet, and that's one of the things that we're hoping future versions will have, but really we're highlighting it through descriptions of the images we're taking and with the measurements as well.
Right. And then just in terms of...
When you say highlighted, you're actually seeing the pump here and the model is here.
Right. But if I were to put that on and I scan a room, I see 4 things that are highlighted. Those are the areas, those are the 4 places where there is a difference between the build condition and the...
You're highlighting it by eyeballing it. You're not...
By eyeballing.
Right.
So you have to recognize that yourself.
Correct.
Okay.
Correct.
So the software with it isn't smart enough to recognize...
Not yet. And that's what I meant by we want to do something about getting the software to automatically recognize that there is not a match here and be able to give you the distances.
And then just in terms of process flow, I mean, it's great you had a room or a floor where the ceiling was exposed. How would this work in real life when you wouldn't get the model till the end of the project and you're having to verify things before the ceiling gets put up? It's
right. You'd have to have the actual project manager kind of check in and before things are closed in, do this process, because after it's closed in, it's too late, so.
The idea here is not to correct reality. The idea here is to correct the model. We're assuming that once reality is done, it's approved and accepted. The concept here is that I want to give you a model that represents reality. So the correction we're making is in the model, right?
I mean, so, some alternative workflows, you could bring LiDAR in before a room gets closed in, but those things are so expensive, and to do that for one room and then not be able to do the next room for a week maybe, that's a lot of cost. And with this, you can just kind of go out, set it up within 10 minutes or so and, verify pretty quickly. So it's just a different workflow. And I mean, I've heard of people saying they went out and measured by hand, but I just don't know how it's practical to measure all those systems and components by hand, so.
Rick, we'll take one more question.
So instead of displaying BIM information, could it be displaying a point cloud?
Displaying?
A point cloud. So let's say we go in and scan that space, captures a point cloud that's not modeled for existing conditions.
That's a good question. I'd have to look into that more.
That's a HoloLive question. Whether they can accept, whether it can upload what type of file on the whole, but that's a good question. Yeah.
I'm inclined to say probably so. As long as you could get it into Navisworks, I would think you can, but don't quote me on that. So.
Last question.
Go ahead, sir.
Last question.
Still trying to understand the difference between augmented reality and mixed reality. It seems like we're seeing both.
They're both very similar. With mixed reality, you're actually, with augmented reality, reality and augmented reality do not interact with each other. Okay? Whereas in mixed reality, you see them both, but exactly. But with mixed reality, the technology allows you to actually see a dinosaur running around you while you're in that environment. And that's how they film.
You mentioned that, but it didn't.
Yeah, it's the interaction. And as you move around it, it's still there. And if it's moving, you can actually see it moving. So the concept is reality and and virtuality are mixed together in the same environment. Okay? Microsoft, I think, have called their new glasses mixed reality, but they're not there yet. But they are, I think they call them mixed reality because they're planning in the future to make the technology works, but it's not there yet.
All right.
Yeah.
Thank you very much.
Thank you, guys.
Thanks.